So yeah, my name's Jack. I'm an engineer at Stripe, as Chris mentioned. I'm not going to talk about that at all today. I'm going to talk about this library that I work on in my free time called Dwift. The core of this library is really just a single function creatively named diff. And it lets you take two arrays and diff them. So the output is a series of this diff step enum. And they're transformations that, when applied to the first array, will result in the second array. So you get this array of diff steps out. And you can see that the whole thing is generic over this type T. So this makes more sense with an example. If I want to turn the word cat into the word facts, we can represent those two words as just arrays of strings. And then we can call diff on them. And Dwift will tell me that I want to delete the C at index 0, and then insert an F at index 0, and then insert a C, and then insert an S. Thanks for subscribing to CatFacts. So the library also exposes wrappers for UI table views and UI collection views. So you can sort of automatically insert and delete rows as you change a data source. And so this is actually why I wrote the library to begin with. This was sort of the problem that I was having in my app. You have like an array of messages or tweets or whatever data you're pulling off of your server, and that's changing over time. And you want to sort of animate those changes into a table view. And so what you can do is you can just set this. There's this rows property on this diff calculator object. And when you set that property, it will diff the new value with the old value, and then that will convert it to a series of table view or collection view that calls to insert rows and delete rows. And so it looks like this. I'm kind of like racing through talking about the library because the details of the implementation don't really matter for the purpose of this talk. So you got this little example app where you have this there's a preloaded list of strings, and when you hit shuffle, it will pick a new. It'll just shuffle them and pick a subset of the strings and display them in a table. And then each time it's hitting shuffle, it's just like setting that rows property, and then the results are getting animated in. And so I told myself when I was writing this library that, unlike every other side project I'd ever worked on, that I was going to do a good job testing my library. Because there's a lot of finicky index math, and so if you get anything wrong, it's obviously like a pretty much immediate array out of bounds exception crash. So I wrote some unit tests. I thought that was sort of that was the obvious first move for me, and so I pretty much just converted that CatFacts example into a Xcode unit test. Right? It's just asserting that those things come out the way that they sort of say they're going to, known inputs and known outputs. And then, so that was fine, and I shipped 1.0, and things were feeling good. And then about 6 months ago, so it was totally stable in production for 8 years. And then people were complaining in my GitHub issues that it was using too much memory because it was super inefficiently written. It was someone else did that part. But there was this weird. So I started rewriting the algorithm, and I refactored the sort of core diff function. And something unsettling started happening where my unit tests were still passing, and I was feeling good, and I almost clicked the merge button on my pull request. But then I would fire up the example app that I showed you, and maybe 15 shuffles in, you would just get a random crash. And obviously not always 15. It was some non-deterministic number of shuffles later. You would get basically an unlucky combination of two arrays, and that would cause some kind of weird edge case, and the app would crash. And so this made me sink into a deep despair. And my despair turned into sort of a hallucinatory mania. It became so profound that I experienced a deep flashback, actually, to the original Functional Swift Conference, 2014 in New York, where I watched a talk by Brian Giesiak from Facebook talk about something called property-based testing. And I'm going to give you a quick and dirty recap of it, but it's going to lack all of his wit and charm. And so if you like this next part, you can go and watch the talk. I actually really encourage watching it. It's really great. It's on the old conference website, so good job past Chris and Brandon for recording that. OK, so if you haven't heard of property-based testing, I like Brian's sort of crazy pitch that he gives in his talk, which is that you don't write tests, you generate them. And so what if you could automatically generate every possible unit test for your function if you're looking to test a function, and not have to write things like that CatFacts test ever again? So again, let's see a little demo of this. let's imagine we're writing this function. Again, details, the implementation doesn't matter, but we're writing a sort function to sort an array of integers. Let's test it. OK, right? OK, start. We'll do some known inputs and outputs. That looks good. But what if there's a bug in our sorting code that breaks with negative numbers, or 0, or if there are duplicates in our array? Right? We have to like remember each one of those possible edge cases sort of up front, and sort of know to write a test that asserts that they don't happen, or like just wait for the app to crash in production and then go back and write a regression test for it. So let's take a step back instead and try something different, and think sort of what are the properties of our sorting function? What should basically always be true regardless of the input and output? So the output should always be the same length as the input. Makes sense. We shouldn't be deleting stuff from the input array as we sort it. Every element similarly should be present that's in the input should be also in the output. And then the output should be in ascending order. Last part, most importantly, well, maybe not. And so that's actually, it's really easy just to convert those properties into code, right? We can just encode sort of 1, 2, 3, the input lengths match, and the output contains the input, and then the array is in ascending order. That's probably an index off by 1 in that last example. So all we need is this magic function at the beginning. We need this magic function called every possible array of integers. And that will just return every possible array of integers in the known universe. And then we're done. And so for each one of these, for every possible array, we will verify these 3 properties are true. And the cool thing is, like, I'm very nervous to throw the word proof around Brandon, but we can feel very, very confident in the qualities of our sorting algorithm if we can verify these things are true for every known array. Obviously, it's not feasible to write this function every possible array of integers, but we can fake it pretty well. We can write a function maybe called lots of arrays of integers. And computers are super good at doing that. That function will generate thousands and thousands and thousands of arrays of integers. And because it's a computer and it lacks many human flaws, it will know to throw some negative numbers in there, and it'll know to try it with 0, and it'll know to try it with some duplicates, and it'll know to try it in all kinds of weird permutations that we never would have thought to write unit tests for a priori. And so if this test passes, we will still, despite the fact that it's not every known array in the universe, we will still feel very confident in the accuracy of our sorting algorithm. But wait, there's more. So let's say we actually did make a mistake in our sorting algorithm. So I've added a really subtle edge case into the algorithm. I'm not sure if you can all pick it up. But so let's say let's go back to that test from a second ago and say we're kind of cruising through that loop where we've generated a lot of arrays of integers, and we're kind of testing them one by one. And so let's just say this is the random, these comments at the bottom. Let's say this is the order we got. So OK, we got 3, 2, 1. That works. There's no 0 in there, and the sorting works, and so we pass. And we get 4, 5, 5, 3. That works. And then we sort of randomly generate one that has a 0 in it, and so that crashes and fails. OK, cool. Well, now this could just return 604 to us, but we don't actually. That's not super helpful. Like, we might not know if our sorting algorithm is really complicated, as my code tends to be. It may not be immediately obvious why that's like a failing example. And so this test can actually give us can actually boost our signal a little bit. So what it'll do is it'll shrink that input. And so it'll say, OK, we failed on 604. Let's try deleting the first and last things from the array and seeing if that example still fails. So we'll try it with 6 and 0. OK, cool, that still fails. Then we'll try it with 6. That works. So let's try the other side. We'll delete 6 and get to 0. OK, so now an array with just 0 and it fails. And if we delete that 0, we get an empty array which passes. So we can have this like super, super signal-full failure case at the bottom where it's saying, hey, your test failed when we try it with just an array containing 0 in it. So it's like, all right, I think I know what's going on here. That's like I said, very quick and dirty recap of what property-based testing is. And there are all these property-based testing libraries out there. They were originally popularized this thing called QuickCheck in Haskell, and that has now been ported to basically every language, including Swift. There are a few of them in Swift. I'll be using one called SwiftCheck for my library in this talk because it ranks first in Google search results. And they all basically give you roughly 3 things that I kind of hastily generalized. They give you these generators that I'm talking about, which are functions to generate lots of arrays. And then they give you ways to compose those generators. So you can say, like, if I have a generator for an integer and I have a I can take two int generators and get a generator for tuples of ints, or arrays of ints, and then like tuples of arrays of ints, which will become useful in a second. And then they've got code to know how to shrink arrays and shrink values, and then usually some kind of DSL for defining properties of your, and then sort of hooking them into your test runner, like XCTest. So back to my problem, I realized, I jolted out of my flashback and realized that conceptually, my example app that I wrote that was crashing was actually a really slow, mediocre property-based test for the library. It requires human intervention. You have to click the shuffle button. So you are the lots of arrays of string or of ints function. And then the property that you're verifying is that the app doesn't crash. But at the end of the day, if you squint your eyes hard enough, it all checks out. So I sort of set the goal of just making my really crappy test better and more automated. I feel like you get a life achievement award if you put this GIF into a functional programming conference talk. So pretty pleased with that. Here's the first test that I wrote. And so it's super janky, but it actually was really useful. So I just want to highlight the sort of the DSL that SwiftCheck exposes. You have this sort of property function, and then you bind, you sort of bind your logic to it. So what I'm saying the app doesn't crash, and then that for all function will, that's sort of the thing that yields each possible pair of arrays of ints to my test. And so that will go ahead and generate 1 million tuples of 2 int arrays. And so, yeah, I'm just firing up a new UI table view. There's a little bit of setup code omitted here, but whatever. I'm making that calculator object I was talking about, and then I'm setting I'm starting in the initial state at that first array, and then I'm switching it to the second one. And so that will animate those changes under the table view. And basically, if that doesn't crash, you return true or false based on what your property is verified. So you just return true. If you get that far, we did it. So this was cool. This was awesome because this actually did verify the issue I was seeing. Like, this test failed, which was really nice. It was my first sort of failing test. The bad news was I didn't get that shrinking example, which is what I really wanted, because so if you think about it, this is just crashing before it gets to the shrinking step. So there was no way of, I wasn't actually getting like a test failure. I was just getting like the test was actually just crashing. And so I did, at this point, what any sane person would do, and I Googled Swift catch fatal error. And that led me to this really interesting library called CWL precondition testing, which Matt Gallagher wrote as part of the Cocoa with Love blog, which is really, really good. And he's got this sort of crazy black magic strategy for handling mock exceptions that lets you effectively do what I'm trying to do here, which is sort of not crash immediately when you encounter a fatal error and give your app a chance to recover from it. And he's all these caveats like this will leak the hell out of memory, so don't ever use this in an app, but it's really useful for testing. I'll link to the blog at the end of the talk too. So that actually really worked. I had to write this little sort of wrapper function. This is basically the same exact test from a second ago, but I've got this catching fatal errors wrapper that just, if you see a Swift fatal error, return false. And it ultimately highlighted a really subtle nuance in UI table view, which is basically when you're processing insertions and deletions inside an update block, it'll do the deletions first, regardless of the order in which you call them. And so under certain conditions, when there was like a delete before an insert, or it was like a weird sandwich thing that would cause like an index error. And it was basically just by luck that the original code was working. And so once I had this sort of shrunk down example, it became really quick to diagnose what was going on. I got the very minimal example of a sort of sandwiched index thing. So fixed things up and was feeling good about that first test, and I wanted to kind of keep following this rabbit hole of property-based testing. And so I decided to write more tests. And so I sort of had to do some reading at this point and sort of see where people suggested I go from here. And what a lot of people said was like a really nice, some things that are nice to test in this way include like reversible functions. So if you're writing, for example, a JSON encoder and decoder, you can generate a lot of sample JSON and then encode and decode it and make sure that the thing that you got out is the thing that you put in. So it's a really nice way of sort of verifying your own logic. It won't tell you sort of if your logic is fundamentally correct. Like you may have a fundamental misunderstanding of the JSON spec and your thing may not actually work, but it will at least be self-consistent. Like your interpretation of JSON is consistent with itself. And similarly, I want to do the same thing for diff. Like I could at least come up with a thing that was consistent with itself. So I wrote the second function called apply. And that is basically the reverse of diff. So you take that result that you get from that original call, this array of transformations, and you apply it to the original array. And that will give you that second array out. And so once you have that function, I think this part was really nice. The test kind of almost just falls out on its own. The property you want to verify is that you can take any two arbitrary arrays of integers, diff them, and then apply the diff to the first array, and you should get the second array. And it feels very, this felt very harmonious to write. Like it feels like it almost reads like just, it reads in a very descriptive fashion, which was very pleasing. And so this actually highlighted another kind of interesting thing that I hadn't considered, which is in addition to being like a huge memory hog, my library was also very slow. So all of my unit tests were testing these like very trivial cases, like cat facts. But now SwiftCheck is throwing arrays of thousands of integers at it, and realizing that I had the SwiftCheck tests were just totally grinding to a halt and taking like minutes and minutes to run. And so I thought that was really interesting. I ended up just going through and making it faster, and now we're all good. But it was one of those things where just sort of like it was almost like a more real world thing of where if I hadn't thought to like put a negative number in my sorting, in my sorting function, I had never tried to actually like write a unit test that threw like 10,000 things into my diff function, which would be kind of an awkward test to write to begin with. But I thought it was really neat that it sort of highlighted that to me in a way that I wouldn't have thought otherwise. So having had the benefit of doing all this and looking back on the experience, here's a quick summary of how I now feel about property-based testing. So I think I was talking to my friend Lisa last night about how it's really easy in like testing talks to talk about how good testing is and how it's great and everyone should do more of it, and the end. But I think it's important to highlight that like it actually was pretty non-trivial to get started here. Like it's really fun to like listen to a conference talk. Like I listened to Brian's talk and then I waited like 3 years before ever actually doing anything in practice with this. And so I think I was trying to figure out what makes it hard and what are like the sort of barriers to entry. And what I've also found is that in general, like I think, if like thinking back to like old iOS testing days when like people just like didn't really write a lot of tests, it's always like hardest to write your first test. And then sort of once you get the first one done, sort of like the marginal cost goes down, and they sort of once you kind of bootstrap up a whole testing suite from there. And so I think it was actually kind of a cool lesson that I would like to impart, which is just like your first test can basically just be that fuzzer that I was writing, where you start at the highest possible level. You just write a thing that says, does my function crash? And just verify that it doesn't crash for any input that you're not expecting. And then once you have that first that first test, then it's a lot easier to kind of think and go, okay, let's get closer to the logic. Let's kind of steer towards the core of this thing, like I did with sort of then going from testing sort of the wrapper for the diff function, and then going to actually testing the diff function itself. If you do write a fuzzer test like that, I would super highly recommend using that CWL precondition testing library, because otherwise it's not very useful because you can't really unwind your failures. And yeah, so I think in general, once for that second test, looking again towards like reversible parts of your code is a really it's a good place to follow your gut. Or if you're having like weird crashes, like that can be generated from some kind of weird state, like this can be a really good way to generate a lot of weird state for your app. And so I'd highly recommend trying it to sort of diagnose your failure. And so that's the bad news. The good news is that for me, it was totally worth it. You get this unbelievable sense of security from testing your code this way. I sort of say it's like the feeling you get when you are working on like an untested code base, and then you write a bunch of tests, like a bunch of unit tests. You basically get that feeling again, going from like a unit tested code base to like a property based tested code base, just like an unbelievable security blanket. And then yeah, your tests, like as we saw, your tests will point out flaws that you didn't realize your code had, like forgetting to handle 0 in your sorting algorithm. And it lets you verify like really complicated, weird systems like Dwift, where you need to set up like that weird state I was talking about. And yeah, and I think Dwift is a lot stronger for having these tests. And that's it. So thank you all so much for listening. Thanks especially to Chris and Brandon for having me. Huge honor to be here.
Do you want to take questions?
Yes, please. Yeah.
So I agree that property-based tests are very hard. For me, it's hard sometimes to come up with meaningful tests. In fact, you have two examples in the talk. The first one, you basically deduced that because the app was crashing in some situations. So you use. I want to do a property-based test to see when my app crashes. Is there a particular reason why you came up with the second one? A particular use case, for example,
Sure.
situation in which you saw, this is not working, so I need this kind of test.
I think so. Going to and testing like the diff function itself, that led to. I think that the failures were more signalful. Like you would see, you're not getting like. I guess the thing that the first one pointed out was actually a misunderstanding of my logic of my understanding of UIKit, and the idea is that like the library is not intended just for use with UIKit. And so I sort of wanted to make sure that it worked in basically both contexts, that sort of the diff is also sort of like self-consistent, if that makes sense. That was why I sort of chose most of the library is kind of, it has that sort of split where there's like the UIKit wrappers and then there's like the core logic. And so I wanted to make sure there was sort of something at both levels. I'm not sure how well that answers your question though. Yeah.
What's the performance like of property-based tests? Would unit tests take a long time to run?
Yes, that's one of the things about property-based tests. Like they're not necessarily designed to be fast, and I think a lot of people have suggested like you can sort of run them with fewer iterations on your local machine, but then maybe in your CI environment you can tweak some environment variables and run them for like overnight or something if you really want to be rigorous about it. So I think it depends. I mean, practically speaking, for me, it's still like pretty instant. Like computers are fast, and I'm not doing anything super complicated here. Like it's just they can loop through 10,000 arrays pretty quickly. But if you want to do something really crazy, like you might set up something more involved. Yeah.
So you mentioned that your library was slow when you started testing it with serious data sets. Did using this approach help you improve that?
Totally. Yeah. There wasn't like I didn't have a very sophisticated test for it. It was basically keep running the tests until they weren't annoyingly slow to wait for. So I didn't do any kind of like, I think I could have benchmarked them or set some kind of timeouts on how long I expected it to take on like known hardware with like known inputs or something. But I didn't even really have to get that sophisticated. It was like, for me, it was the difference between like the test suite takes 5 minutes to run and like the test suite is instantaneous. So once I got to that part, I was like satisfied enough. I mean, there's like tons of, I just had never profiled the code before, right? So there's tons of like immediately obvious things that were way faster upon just putting any attention into it. So, yeah, in the back. That's a great question. I thought about that a little bit with Dwift and what I want to do. Like basically, like, can I delete the old tests now? And I think for now, they're useful as regression tests. So like the things, I kind of keep them around specifically to catch the things that I knew broke before I had the property-based testing set up. I was looking at some other, so like the Python quick check implementation is called Hypothesis. That's I think the best known one. And they had this really neat feature where they'll basically save any failures they encounter into a local database. Like the library will just do it for you. And then it will, when you run the test, it will replay those failures first. So it'll kind of keep track of your regressions for you as part of the framework. I think that would be really cool. I think if Swift check had that, I think I would probably delete my other tests because they seem pretty redundant now. They seem pretty trifling and insignificant compared to the power of Swift check.
Last question.
Oh yeah.
So to continue the previous question, I find often that when I write unit tests, it helps me to guide the design of my classes or functions or what have you. While this is like the property-based testing is quite similar because you still call the APIs. It's a bit more of kind of friction. So when you write new functionality, do you start with unit tests to help you guide the design, or you start with these guys? Because this is more like test the performance, test the errors that I didn't think of, but not necessarily about the design. And what's your experience about actually helping you provide better APIs?
Yeah. So I haven't ever done that really. So I'm still relatively new to it, right? So I've never sort of sat and had property-based tests be the first test that I wrote for a framework. It'd be cool to be able to go back in time and start with that here. I think like in an ideal world, I feel like if I were to keep doing this, I think that like that friction I was talking about would go down, where it becomes more and more natural to write those tests, where you just like start sort of dreaming in properties and can describe them really easily. It also probably totally depends on what you're writing. Like there's some use cases, like I think this is like a really good use case for this, and so I think it's probably among the easiest things where you could start by writing property-based tests, but it's not going to work for every application. So I think there's definitely cases where it's just a lot easier mentally to kind of start by writing a couple of just like inputs and outputs. Yeah, hard to say. I think it's possible. I think it would be cool if you could do it. Like, and if your brain was sort of sufficiently adjusted that way, I think there's nothing that would stop you from doing it conceptually. All right. Cool. Thank you all.
More later.
Yeah, I'm around.